Hey everybody, Mr. J here from Organized Biology. I'm so glad you're here, and I think you're really going to like this lesson. And in all of my years of teaching anatomy and physiology, this is the lesson that usually sticks with my students the most. In fact, when they go home and tell their families about it, their minds are usually blown as well. So well done. Thanks for clicking on this video. So we're all talking about how your brain rewards positive thinking specifically, but I'm going to get into some details of other things that can reward your brain. And this is a concept called neuroplasticity. Now, that's just basically a fancy way of saying your brain can change. You are relatively plastic or malleable inside the neurons or the cells of your brain. So before we get into the details of it, I want to put a disclaimer that this model I'm going to show is not a fact. We can't support it scientifically and say this is the model of how it works, but it's a really good model of how to understand the complexities of these neural connections in a very simple way. So let's get started. All of us have pain and stress and other things that are just worrying us day to day, right? So maybe you have back pain, or maybe you're worried about your firstborn daughter who's going off to college next week. So we all have these different stimuli. I'm going to call them stimuli. And they're going to come into our bodies, literally our brains, and they are going to trigger these stress response neural circuits. What do I mean by neural circuit? Well, anytime a neural circuit fires, basically gets excited and sends a signal through them, this basically represents a thought or an experience. So whenever you get these stressful, painful stimuli, these neural circuits are triggered. Now, why do we feel this anxiety and stress when we do them or when we experience these things? Because we're preparing to fight off whatever danger is coming or run away from it for that matter. You see, what's interesting is our brain doesn't know how to differentiate a saber-toothed tiger running at you versus a test or versus an angry daughter or a person who's just annoying you a lot. All of them are stress to your brain, so you get the same stress response. But the problem is we don't want to be super duper stressed just for a test. We don't want to be super duper stressed when our daughter's going off to college. These are just kind of mundane things that we don't need to get stressed out about. So we have a way to modulate these neural circuits even when these stimuli are coming in. One of the neuromodulator neurotransmitters, fancy words, is called serotonin. So I'm going to point at this little molecule in here. This is called serotonin. You may have heard of it before as the happy or content neurotransmitter. So I'm going to write that. Even though it's not legitimately true, it's more of a neuromodulator. It modulates different neural circuits. But I'm just going to classify that whenever we release serotonin, so say we release serotonin here, what it will do is actually dampen this signal. Okay, it's kind of like pouring water on a fire. So if we release the serotonin, we'll actually make these neural circuits relatively negatively charged. So inside the cell, they get negative, kind of an interesting idea. And if they get negative, they actually don't send their signals. So if they don't send their signals, guess what? You don't experience that stress or pain or anxiety, which is a wonderful thing. And I bet you want that. But the question is, when does this guy, this neuron with the serotonin, actually release it? When does this happen? And that is the question we're going to figure out today, okay? So this is a serotonin neuron. Now, all of these, I've said the word neuron, it's just the cellular unit of your brain. You've got 100 billion of them in your brain alone, and they exist to send these signals, release these neurotransmitters, basically chemicals, just like serotonin is, therefore changing another neuron and sending signals and stopping sending signals. So over here in the serotonin neuron, just keep in mind that we want to fire this guy. If we fire this guy, we are going to release serotonin and not experience stress as much. That's a good thing. But as you can see, we've got a lot of other neurons who communicate with this one, right? We call these guys presynaptic neurons. Presynaptic neurons. Not just these black ones, but also the pink ones. They're all presynaptic. Why is that? Well, you see the space in between where the neurons are talking to these guys? This space is called a synapse, so these all come before the synapse. And when these three black neurons, they're not actually black in your brain, but just a diagram, when they send their signals, they're actually going to release an inhibitory neurotransmitter. Okay, so I'm going to label these as inhibitory neurotransmitters. And they're just going to be chemicals that make this neuron more negative. And if you remember what I just talked about, when neurons are more negative, what don't they do? Well, they don't send their signals. So these guys are actually going to inhibit this one. How do you think that would make you feel? Well, if these guys are firing negative inhibitory neurotransmitters, this guy gets negative, guess what? He does not send his signal. If he doesn't send his signal, neurotransmitter is not released. Neurotransmitter is not released, guess what? These guys are now going to fire and you're going to feel relatively stressed, correct? Here's what's interesting. These inhibitory neurons are activated when you are actively thinking negatively about a situation. Okay, so they're activated when I'm just going to say negative thinking. Okay, so you're like wallowing in yourself, right? So maybe something happened at work, somebody talked to you bad, and you're just mulling over it in your head, mulling over it in your head. You're getting really frustrated, you're getting really stressed. Why is that? Well, two reasons. Number one, it's a painful, stressful stimulus. Number two, you're wallowing it, right? Negatively thinking, therefore you're inhibiting your serotonin neuron, no serotonin, and now these guys are just going crazy, right? Because they're not getting inhibited by the serotonin, and you feel like crap. So, how do we counterbalance this? Well, we also have neurons in our brain, and they are going to send their signals at some point and release stimulatory neurotransmitters. We like these guys. Because if they send their stimulatory neurotransmitters, it makes it more likely that this guy will get positively charged. And whenever these neurons get positively charged, they send their signals. If you want to know what the signal's called, it's called an action potential in A&P. And that action potential will lead to the release of serotonin. That will then cut off the signal. Do you kind of see this interplay here? We've got two kind of battling it out neuron types that are either going to inhibit or stimulate this neuron to release serotonin. Now, what's interesting about these guys here is that they are activated, you can probably guess by the way I'm leading you into this, they are activated by positive thinking. When you think positive about a scenario, for example, from the Bible, pray for your enemies, right? And bless those who persecute you. So if a person at work is bothering you and instead you're like, hey, you know what? I'm just going to let it go. I wish the very best for them. Hey, you're changing that into positive thinking. You're sending these neurons out, and it makes it more likely that you'll release serotonin, and you'll feel better about the scenario. Isn't that fascinating? Now, here's the problem. Let's say you don't want to do that. Let's say you want to wallow in your self-pity. In that case, you're going to be firing these neurons a lot, right? And as we mentioned, when we fire those neurons a lot, this guy is going to get very, very negative, and it's not going to send that signal. And we're not going to release serotonin. The problem becomes this neuroplasticity. Yes, it's a problem at some points because if you use these a lot, they are going to continue to get stronger. So let's say you negatively think a lot. What will happen is these neurons will actually grow closer to its target. Not only will it grow closer to its target the more you use it, but the more neurotransmitter it will release per signal. So now you're releasing a lot, whoops, what am I doing? Now you're releasing a lot of inhibitory neurotransmitters from these guys. What do you think that'll do to this neuron? Well, it'll force it to get even more negatively charged. Negative, 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 negative. And now it's really impossible for you to release serotonin. You're going to feel like crap. So that's why it's really bad to wallow in negative thinking. But the reverse is also true. Let's say you say, screw it, I'm never going to negatively think again, or at least try not to. These guys won't fire as much, and they will actually grow backwards. So you're not negatively thinking as much anymore. They're going backwards, and they won't release as much neurotransmitter. That is neuroplasticity. But what I want to point out is the same is true on the other side. Let's say every day you're going to wake up and you're going to be grateful. You're going to think of 10 things you're grateful for. Well, guess what? These guys start firing more and more and more. They start growing more and more and more close to the target cell. and they're going to release more stimulatory neurotransmitters, making it more likely, as you guys can guess, make this guy positive, send the signal, release serotonin. Isn't that amazing, right? So the more you use one, the more close it gets, the stronger that signal. The less you use one, the further back it will get. So the people in your life who are generally more happy and content and healthy, interestingly enough, are the ones who can think positively about scenarios. Now, that's not the only way that you can send these neurons, but you can also exercise. Exercise is a natural booster of serotonin, as well as things like meditation. So all of these are tools in your toolbox to help increase your serotonin levels to feel less stressed, less anxious, and less in pain. Now, that being said, does that mean that this will always like heal you or give you a serotonin boost? Absolutely not. Some days are harder than others. Some days are easier than others. So give yourself some grace there. But what I want to encourage you with is Philippians 4:8. It says, whatever is good, true, noble, worthy of praise, meditate on these things, and the God of peace will be with you. That scripture is actually really in line with the biology of your brain, because the more you meditate on good things that God has given you in this life, in my opinion, I'm a Christian, the more your body actually rewards you. And in a way, it's kind of God's way of saying, hey, peace, be still, all is well. Hey, thanks for watching this. If you found this interesting, please like this video, subscribe to the channel.